So good morning. Today we'll continuing with the concept System Software Compiler Design Module 3. The contents that we covered in the previous classes: introduction, the language processors, the structure of the compiler, and the science of building the compiler, that is compiler construction tool, and the applications of compiler technology. And along with that, difference between compiler and interpreter and working principle of the compiler. Now we move on to how that each phases are going to be implemented and how each phases are going to be converting the one syntax into another syntax, right? Okay, let me start with one simple example. So where it is going to be representing an equation. So here we are not considering complete program as a reference, just we are taking a single line of execution, and by considering that single line of execution we'll checking what exactly that each phase, how that each phases are going to be traversed, and finally how that object code or machine understandable language are going to be generated, that is with reference to 7 phases of the compiler, right? So assume that firstly and simple arithmetic expression statement, position equals to initial plus rate into 60, right? So as we know, position is also a variable. It will be any data type. Initial is also a variable, again it will be of any data type, and that we are going to be computing addition with the rate, and it is multiplied with a constant 60, right? If I pass the same statement for a lexical analyzer, the lexical analyzer job is to consider the sequence of character and align it as a meaningful lexemes, or we can call it as a smallest unit of the program, that is a tokens, right? So it will be generate an identifiers, that is a tokens, based on that expression specified in a given program, right? So in the given program, assume the position is assigned with an id1 and equals is an assignment operator, then initial is assigned with id2 plus is an operator, and rate is assigned with id3 and star is an operator, and 60 is a constant, right? Once this part is completed, so as you can look at with the right side, symbol table is generated. So what is the symbol according to the particular statement? Just by considering the single line of process, the 3 different type of arguments are going to be added for a symbol table. So position, again initial and rate, right? And since we are not declare that value, since we are not initialize that value, right, just position and initial rate will be filled and the corresponding value will be empty. So that looks how the symbol table in a compilation process. After lexical analyzer generates the tokens, and the next phase is your syntax analyzer, right? What is syntax analyzer? So as we know, in the previous class we are discussing, once the IDs or tokens are generated from the lexical analyzer, the role of syntax analyzer is going to be represents an parse tree, or we can call it as a syntax tree, based on the IDs that is generated from the lexical phase. The output generated from the lexical phase is accepted by syntax analyzer, and then it is represented in terms of a syntax tree or parse tree, right? And next, syntax tree generated from the syntax analysis will give us an input, and that is forwarded as an input to semantic analyzer, right? That's a phase 3 of your compilation process. In that particular phase, the semantics analyzer, it is going to be verifying what type of data, error checking, syntax analysis, all the process is going to be verified in that particular semantic analysis. Just check with the previous phase to present phase. So where the 60 is the value that is going to be assigned it for constant, right? But when it comes to semantic analyzer, it is identifying whether the 60 is of integer data type or 60 is to be converted into floating point data type, and whether it is 60 is an ASCII value of any character. Each and everything is going to be analyzing it based on that instructions or input given by an user. Once it is identified, the semantic analyzer, it will conclude it after validating the syntax. Finally it will add with that particular data, right? And after semantic analysis, next is your intermediate code generator. What is intermediate code generator? Intermediate code generator, it start evaluating that expression, it start evaluating the computation. So firstly, it is checked with the constant. According to given expression, 60 is a constant, that is going to be converted to a t1, that is assembling into t1, and it is converted integer to float, and then that value is going to be multiplied, that value is going to be multiplied with id3, that value is going to be multiplied with id3, and that is assigned to another variable t2, and the t2 is going to be verifying it as an addition of two numbers. Addition of two numbers is going to be computing as a t3, and the t3 is assigned to an id1, right? So id1 specifies the resultant value. ID1 specifies resultant variable, right? After processing of intermediate code generation, next phase is your machine independent code optimization. Means how we can optimize or minimize, how complexity is going to be reduced. That can be implemented with a machine independent code optimization. So instead of representing 4 different syntax, the 4 different processing lines, that machine independent code optimization will minimize or optimize into 2 separate lines. So by using the 2 separate lines, user is computing the same process, but it is minimizing to efficient analysis or to minimize to faster execution. And nextly, code is going to be generated based on the instructions, right? ID3 is going to be loaded as a floating value to an R1. Then again you will be performing multiplication, and F stands for floating point value. And as you can see, so immediate value is going to be taken, and that immediate value is going to be multiplied, and resultant is going to be stored in R1. Next again you will be loading that ID2. Again it is going to be loaded to R2. Then we are applying addition of that R1 and R2. Then we are going to be finally storing in store instruction, that is ID1, right? This is how that each phases are going to be executed if we consider a simple mathematical computation expression. Same thing is applicable for all the syntax. If you are applying if condition, same process will be carried. If you apply a iterative statement like for loop, same process will be carried out. If you applied while loop, same process. If you're writing C, C++, Java, any type of programming languages, any type of compilation involved languages, always follows with same sequence of process, right? So this will give some the programmatic flow how can be done by compiler, and each phases how it is going to be integrated as a single phase of a compiler. But generally it is going to be performed by single phase, but again it is subdivided into 2 separate process, and within 2 separate process it is added with a total 7 number of phases. So 7 phases of the compiler, right? And nextly, so when you're having simple another example, like if you're performing array operations, how that array operations can be evaluated, right? So if I consider a of index equal to 4 plus 2 plus index, if there is a single sequential statement of input, then how that lexical analyzer is going to be accepting it. So as we know, lexical analyzer, it generates a tokens, that is an ID is going to be generated, that ID1 for A, and even that opening brace is an operator that will be represented as it is, and again index is an ID2, then closing brace will be represented as it is, then again equal statement, assignment statement, 4 will be assigned as a constant, plus is an operator, 2 will be assigned as a constant, and again plus is an operator, and ID2. So basically we will be generating with an 2 IDs. So don't confuse here. Index is an one value, index is in one variable, hence it is allocating with a common identifier, so it will not going to be duplicating it. But one symbol table is generated, 2 indexes are going to be filled, 2 values are going to be, 2 columns are going to be filled, and first will be A and second will be index. Since only 2 identifiers are generated, but in the previous example 3 identifiers, position, initial and rate, 3 identifiers are going to be generated, but in this example only 2 identifiers. Next, if you represented after syntax analysis, next if you represented in the syntax analysis after the process of lexical analysis, how that particular syntax tree or parse tree is going to be represented. So as you can see, the subscript will be there, that is connected with A as well as index, and again equal symbol, and again with the RHS 4 plus 2 plus index, as it is going to be represented. And next phase is your semantic analysis. And again in the semantic analyzer, if there is any type checking, cross checking with any syntax error, logic error, each and everything is going to be identified. And next part is your intermediate code generation. As we know, intermediate code generation, it will minimized with an simplified instruction process, right? And intermediate instruction 4 plus 2 is assigned to T1, then again T1 plus index will be assigned to A of index, right? And if is any possibilities will be there to minimize that intermediate code generated, then again next phase is your machine independent code optimizer. So in simple terms, you can perform instead of 4 plus 2 by storing in another variable, directly you can compute 6 plus index and store it in A of index, right? And next phase is your code generator. So in code generator, just observe here, R0 value, that index is going to be assigned, index whatever will be there, that will be assigned to R0, that is index will be assigned to R0. And nextly, address, starting address of array, right? Very important, starting address of array. So R1 will be processed, means starting address of array will be stored it in R1, that we are going to be moving here, right? And nextly we are applying addition, R0 and R1, so that you are going to be performing addition. Next, afterwards you are immediately moving whatever that value 6 is there, that is going to be R2 register. So then we are applying R1 and R2. So R1 and R2 is going to be adding together. Afterwards you are moving R2, that is store R2 in address of R1, that is a value. So this will give how exactly, if I consider an array index as an example, but previous example we suggest how exactly mathematical equations are going to be computed. So this two example gives how the compilation process can be carried out. Same thing you can trace out for different types of expressions, equations, syntax of either C, C++ or Java program, right? And nextly, environment and state. So I think you all know about what exactly automata theory and computation. There, when you are writing the representation of deterministic finite automata, you'll be traversing with the each state. So each state you'll be identifying upon some certain input, you'll be moving from one state to another state. Initial state, intermediate state, followed by final state, right? When you will be reaching the final state, that language is going to be accepted. If you're not reaching the final state or the input is not traversed properly, then that language is not going to be accepted. So that type of language is called non-deterministic finite automata. Again, when you're representing a DFA, if you're coming across with a trap state, then that type of language is nothing but non-deterministic finite automata. If the strings are terminated, then it will be considered as an deterministic, means you can easily determine the sequence of character, sequence of string or valid data, right? So as you can see with the diagrammatic representations, environment and state. So whenever you are having Q naught, upon some input, you will be transiting from one state to another state. So two status you can specify. Assume 0 and 1 are the input. Upon 0, it is moved to Q1. Upon 1, it will be moved to Q2. Means the transition from one state to another state is referred as environment and states. So either you can call name. Name will be environment to the location, and location state will be values. In terms of programming syntax scenario, we will be considering name, environment, location, state as well as values, right? So what is environment? Environment is mapping names to location in the storage area. So what exactly environment means? It is mapping your name to the location. If I call a is equal to 5, a equal to 5 means that environment is mapping the name to the location 5 where exactly it is going to be stored. What is state specified? State is a mapping from location into store their values. So finally you will be retrieving that particular value in a memory address. That's why we are representing environment and state, right? Nextly, what is dynamic mapping exceptions? When you are writing the program, so as we know, each and everything is going to be binded as an static dynamic, and again it is also represented as an scope. Within that particular scope or within that particular region, either we can call it as a local variable, it is restricted within a class or within a member function within a function. Global means it is allowed to access either outside the class and throughout the program. So if I take static binding of names to a location, global variable declarations will be there and locations of the data will be available, and again it depends on the segments: data segment, stack segment, heap segment, extra segment. Based on the segments, the values are going to be stored, right? And same example, as you can see, int I is represents a global I, local I it represents an within a function, right? And global will be in data segment, normal data will be in normal segment. When it comes with the second scenario, state binding of location to values. In the previous example, names to location we are verifying it, but in the next one, location to values we are going to be verifying. So if I consider an example, macro definition like hash define array size 100, so that specifies static bind, means statically we are specifying a value 1000 for an array size. So we are defining, and throughout the program the value is going to be common, means in that particular location which identified that array size, it is immediately replacing with a particular values. So that gives a static bind, so the values are going to be constant, right? And look with another diagram, static scope and block structure. So what exactly static scope and block structure? When you're writing the n number of functions either in a C, C++ or assembly level language, 8085, 8086 processor, n number of functions you can represent, and generally that is going to be represented as a blocks wise we will be writing, right? And block represents a modules or a method or a function. So when you are having the blocks, and the blocks is going to be having that complete access within that particular block, right? That static scope will be there, dynamic scope will be there, global scope will be there, local scope will be there. That representation will be called as static scope and block structure. As you can see it in the block 1, a equal to 1, b equal to 1. In the block 2, b equals to 2. In block 3, a equal to 3. In the block 4, b equal to float. Means the block wise we are going to be segregating the value that specifies how values or how the scope of the data is going to be represented in terms of blocking process. So if you consider the same example, declaration and scope, A equal to 1, that scope is B1 to B3, and B equals to 1, B1 to B2, and B equal to 2, B2 to B4, A equal to 3 and B3, int B equal to 4, that is for B4. So like that we can segregate how that scopes are going to be restricted, scopes are going to be represented. And consider with the second example. So here we are creating one main method, and then later we are declaring a local variable of integer data type wxyz, and integer we are initialized with I equal to 4 and integer j is initialized to 5, right? And within that block, that representation of the square representation, int j equal to 7, I equal to 6. So in the outside block, j equal to 5, but within block j is equal to 7. If you're computing w equal to I plus j, and if you're trying to printing the w value, observe in the syntax, j is declared as a 5, but within a block it is declared as an 6. Hence, even though if you declared as I equal to 5, it is not going to be taken by your compiler. Instead, it will take it with a recent value. So the recent value of j is 7, hence 7 plus I. I will be taking previous. I will be taking as an initial recent value only. So 6 plus 7 will be computed as 30. And in the next expression, if you are not considered as a block representation, x equal to I plus j. So x will be considered as an recent value. So what is the recent value? The recent value of x equal to 6, and what is the j recent value? The j recent value is going to 5, right? So finally that value is going to be printed as 11. And in the next block, I equal to 8, and now you are printing y equal to I plus j, right? And y equal to I plus j, where I is going to be added as 8, and again j is going to be represented as 5. Now the value is going to be computed as 30. Like that, blockwise representations user can be update for a particular type of syntax of the program. And similarly, another example is there, similar to same two previous examples, but only it is restricted to how the functionality method wise the programs can be executed, right? And another example, how we can declare it in a block representations. So each value after initialization is always takes with an recent value. That recent value we are computing with an initial process of an all the syntax of your programs. And here some assignment questions are there. Reference question, so identify with the logic and how the functions are going to be represented, and how that compilation is going to be created for specifications of preprocessor macro representation. As define a equal to x plus 1, and if I assign x equal to 2, that 2 plus 1 is obviously equal to 3. Like that, you just trace out with all the syntaxes of example. In the exam, there may be chances of asking by giving a simple code snippet block of the code, they'll be asking what exactly that particular output, and based on that you'll be analyzing lexical, syntax, semantic and corresponding phases. So that is very important programmatic and technical type of questions. Next we move on to parameter passing mechanism. So again, it is similar to your C++ and Java program, how we can pass a parameters. Parameters where the passing methods can be represented in either call by value, call by reference or call by name. So the different methods are there. So call by value and by call by reference are the basic methods that we are using in a C++, but call by name that is going to be used in earlier program Algol 6.0, right? So again, it is a continuation of your C++ program, and same example you can refer for the C syntax and C++, same we are representing for a compilation process. And example is given that call by value, there we are not representing with a pointer concept, but in call by reference we are representing with a pointer concept. And again, with the call by name we are using aliasing concept. When you are running any scripting programs, we are using an aliasing concept in Unix and shell programming applications. Again, aliasing means alternate name assigning as a reference parameter. So that is a reference variable concept in Java programs, right? And these are all the questions that is asked in the previous semesters. So basic questions like what is compiler, difference between compiler and interpreter, what is example, with specifications you can give it as an compilations and interpretation process. And number 3, explain the language processor system. Number 4, describe analysis and synthesis model. Just observe here, either in the exam explain the different phases of the compiler, or explain analysis and synthesis base of compiler, explain front end of the compiler, explain back end of the compiler. Like that, n number of sequences of questions will be there, right? It's up to you. When identify the question and based on that verify with the marks. Identify the question and verify with the marks, then write the solution for a given question. And some examples are given how the phase of compilations is carried out with the help of different mathematical equation, arithmetic equations. And if you want, you can trace out and practice with an logical syntaxes, logical manipulations, iterative statement. And again, you can also represent in terms of Python application programs. By taking Python syntax also, you just track out, but here compilation is not there in the Python language. Python is in scripting language. Just trace out with an interpretation how that languages can be interpreted, how the Python high level language will be interpreted into machine understandable language, right? Why is it necessary group the phases of the compiler? So basically, in all the textbook, I think everything is going to be given in the form of a layered architecture, same as your computer networks, TCP, IP, and OSI. Again, in the C compilations or C++ compilation, the phases are given. The reason is nothing but by making the phases, by grouping the phases, always helps in efficient processing of different languages. So if you make it as a different phases, and we can easily identify what are the different types of errors that comes in a different programs, right? If you make it as a single phase, it is very critical to identify and debug the problems that is arised in a program. If you make it as a different phases, each phases has their own roles and responsibility, and any process will be there or any errors will be there that will be replicated within particular programs or particular syntax of the particular phases of your compiler, right? So that's why the reason we are going to be grouping the phases of compiler. Easy to debug, easy to recorrect, and efficient and effective approaches of the program. So for all the reasons, we are using phases for a compilers. And what is the purpose of compiler construction tool? Describe with different types of scenarios. And nextly, analyze the software productivity tool and explain the different parameter passing technique with an example. That is again continuation of your C program basic questions, right? And this is a module 3 chapter first, very simplified type of applications we can represent it in terms of compiler, and how the phases will be there problematically, how we can phases of the compilation is represented for normal statement or iterative statement or compilation with any logical statement, you can trace it, right? And in the next class, we will start off with the next chapter in the same module, lexical analyzer, and how the lexical analyzer is going to be implemented with complete scenarios, example, and all. So thank you for watching. And next, if you have any queries,